Hello, kinematics, motion in two dimension. So, in order to study motion in two dimension, we require a reference point, which we also required in motion in one dimension. And we require two reference axes. Later on, I'm going to tell you about motion in three dimension also. So there we would require three reference axes and a clock for time axis. These together form frame of reference. With respect to which we are going to study motion. But the concept of frame of reference is essential in when we are going to study about the dynamics. Means when force and other effects are also being studied. But till now, we are just focused, uh, we will just focused with those coordinate axis and a reference point. That's all. Okay, so now quickly some foundational concepts like position vector. So like in coordinate geometry, we assign some position with the help of some coordinates. So also in physics, we will follow the same criteria. So if there is an xy plane, there is an origin, and there is a point, and its coordinates are x and y. With respect to this origin, sometime it is called arbitrary origin. Actually, its choice is arbitrary. So, in fact, in maths, in coordinate geometry, whenever you have drawn a graph, you have chosen an arbitrary origin there. Okay, but if we talk about vectors, then there is an origin because we are observing the motion with respect to this O point. And if we are observing this point, then this arrow will show not only the direction of that point, but its length will show the distance of that point with respect to this origin. And we will represent uh, entire this length as well as this direction in terms of a vector which is called position vector. It is represented by r. Generally, we use r as its symbol, position vector. Don't get confused with radius. For radius, geometric radius, we are going to use capital R. But for position vector, we are going to use small r. So if its coordinates are x and y, it means the projection of this r on x-axis is x, or I can say that its coordinates are like x and then y. But as I told you, the in terms of projection, yeah, that should also be kept in your mind. Like if this is a rod and I am glowing a lamp from this side over it, this is a lamp, then it will cast a shadow on x-axis. There will be the shadow. in the same manner, you can see here, this R has a component along x-axis which has value x, or we can say R has a projection on x-axis which has the value x. Both statements are correct. In the same way, if I glow a lamp, a light from this side using a lamp, it's not looking like a lamp, but still consider it as a lamp. So it will cast a shadow this way. So this value is y, this value is x. All right, so here it is. Ultimately, the vector value of R is equal to x I cap plus y j cap. This is what the vector value of R is all about. And also R is equal to root of x square plus y square. Why is it so? We can say that in vectors we have studied this, that if there are rectangular coordinates, there are rectangular component of a vector, then we can square them, add them and take root. That will give the magnitude, or simply we can say we can apply Pythagoras theorem and we can find magnitude R. So this is all about position vector. Okay, next is displacement vector. So displacement vector will represent by delta r or sometime dr also. So let us suppose again we have same set of coordinates, and earlier object was there at point A, and then it moved somewhere here at point B, and if its coordinates are xa, ya, and its coordinates are xb, yb, then this is RA, position vector of A, and this is RB, position vector of B with respect to O. Here also with respect to O. And A to B, it is, let us suppose it has started from A and it reached B, then this will be the displacement delta R. This will be the displacement. So this delta R is equal to this RBO minus RAO. Now who told us that this delta R will be equal to RBO minus RAO, and why not RAO minus RBO? And by the way, why subscript O? Because this is position of A with respect to O. In some books they write OA. That's a different meaning why they write OA, but in most other books it looks like this. So don't get confused, just keep the symbols in your mind, because in the exam they are not going to give you such type of confusing terms. They will explain that what their symbol represent, whether their subscripts are showing what with respect to what. So it will be explained in the question itself. So I'm taking these as this RAO means position of A with respect to O. So I use this as a symbol, as a representation. Okay, now moving on, if we can also write it as XB I cap plus YB j cap minus, and see minus it is. So why I am writing it like this? Because I know that r is x I cap plus y j cap. So for a it will be x a I cap y a j cap, and for b it will be x b I cap and y b j cap. So it will be x a I cap minus, I hope you can understand why minus here also, j cap. So furthermore it will be xb minus xa I cap plus yb minus ya j cap. And if we want to find magnitude of this position vector, then it will be xb minus xa square plus yb minus ya square, and which is the distance formula. So ultimately the distance formula, we arrive to the uh, distance formula using position vectors, and this is what we have learned in class 10th, where there were 2 points and we have to find distance between them. So remember, this is not the order sensitive, but this is order sensitive. If this is initial position, this is final position, then always you will subtract this with this. And I can explain it with reference to vector diagram also. So in vectors there is a triangle and these two sides are taken in order. So they will be the sides which add together, and this will, which is out of the order, it should go, because if we take order it is going like this and it should go like this if we follow the order, but it is not going like this, it is going out of the order. So that will represent its vector addition, RBO. So from here R is equal to RBO minus RAO, or simply we can say that this is the final position, so final position minus initial position. So that's all about displacement. How we can find it, how we can find its magnitude as well. Okay, moving on. Now velocity vector. So let us suppose this is the position vector x I cap plus y j cap. Then the, if we differentiate it with respect to t, then yeah, of course differentiation is new thing and quite difficult also, but here it is very simple one. Dr by dt is overall velocity vector, of course, and here it is vx I cap plus vy j cap, and we know this thing, vx square plus vy square. And in the same way acceleration vector, so we have v equal to vx I cap plus vy j cap. So again we can differentiate, dv by dt is equal to dvx by dt I cap plus dvy by dt j cap. So this becomes acceleration, and it is acceleration along the component along x-axis, and this is the component along y-axis, and its resultant will be root ax square plus ay square. So in all of these concepts, if we take a summary of it, you can see there are two components all the time. So in order to solve the problems based on motion in 2 dimension, we can uh, work upon the components. So how are we going to proceed? So I am giving just a simple example here, and you can find some different problem based upon the this uh, this concept. So but I hope this example will help you a lot. So there is a particle which is moving with a velocity whose component along x-axis is 5 meter per second and along y-axis is 2 meter per second. If it is accelerated by an acceleration whose x component is minus 2 meter per second square and y component is 2 meter per second square, then find number 1 velocity, number 2 displacement at the end of 5 seconds. Clearly, this is the question of motion in 2 dimension, because velocity is not only in along x-axis but also along y-axis, and also the acceleration is not only along the x-axis but also along y-axis. It is not needed that all the time the component of velocity should be along x and y both the axis, and acceleration should be along x and y both the axis, but one of them should have a component along x and y axis, both the axis. So we can solve this problem separately along x axis and along y axis. So along x axis, in order to find velocity, we can write Vx. It is not the final V, but the x component of V is equal to Ux plus Ax t. Remember, t is a scalar quantity. Don't put subscript to it. We can apply vector, or in fact we can leave it as it is also. We can apply vector sign in the end also, because it is already in 1 dimension, so needless to put vector sign here. So Vx will be Ux, x component of velocity 5, acceleration along x axis minus 2, and time is 5 seconds. So it is 5 minus 10, that is minus 5 meter per second, and it is the component along x-axis. Remember that this is Vx. Now same way, Vy equal to Uy plus Ay t. Uy is 2 meter per second. Acceleration also 2 meter per second square time 5. So it will be 12 meter per second. Now in order to find resultant velocity, okay, actually it is not asked in the question, but I am going to express final velocity in two ways. First in vector form, v is equal to vx I cap plus vy j cap. Vx is minus 5, so we'll put minus 5 I cap plus 12 j cap. This is v in vector form. And in magnitude wise, if we want to find magnitude, we can directly find its magnitude, or we can take directly values from here and here. So v will be equal to root of minus 5 square. Actually, I encourage students to directly write 5 square, because we take that value of that component with its sign. So if it is minus, so there will be square of minus also. So no need to put that negative sign while measuring the magnitude. And this is 25 plus 144, which is 169, which is 13 meter per second. Same in the same manner we can do it for displacement, but now I am going to tell you a shortcut for this. This was just in order to give you an idea how we can just resolve a two-dimensional motion into two different one-dimensional motions, and then when we can club them together. But what else we can do? We can do it directly also. So if I write initial velocity vector as 5 I cap plus 2 j cap meter per second, then it is much better to understand. Okay. In the same way, acceleration vector is minus 2 I cap plus 2 j cap meter per second. And now it's quite easy. V vector is u vector plus a vector t. U vector 5 I cap plus 2 j cap plus minus 2 I cap plus 2 j cap multiplied by 5. 5 I cap plus 2 j cap plus not plus minus 10 I cap plus 10 j cap. It is minus 5 I cap plus 12 j cap. And we can find the magnitude, so you can do it yourself. And in order to find displacement also, because that was also the part, why I have not done it through this way, otherwise it would be lengthy. So you can do it that way also. I'm skipping it. I'm directly doing it in a vector form. So S vector is equal to U vector t plus half a vector t square. So U is, there it is, 5 I cap plus 2 j cap multiplied by 5 plus half acceleration minus 2I cap plus 2j cap multiplied by 5 square. Now it is 25 I cap plus 10 j cap plus, if we divide it by 2, it will be minus I cap plus 2, oh sorry, plus j cap, and 25 it is. So finally it is 25 I cap plus 10 j cap minus 25 I cap plus 25 j cap. Okay, so finally it is 35 j cap. Final motion is along y axis only. That's surprising, but that's true, and you can solve it your way also, and you will find that the result is this. And if we want to find its magnitude, no need to do square root and on, because it is this only the single term. So s is equal to just 35 meter. I forgot meter. You can do the same thing by considering uh, motion along x-axis and y-axis, and then you will find s along x-axis and s along y-axis. So I suspect that Sx will be 0. You can find it out of your own. This is how we are going to do these type of problems. And now before I end this video, I am modifying the equations of motion in vector form. So now v vector is equal to u vector plus a vector t. This is the first equation. Second is equation s vector is equal to u vector t plus half a vector t square. And third one is much interesting. We can't write v vector square. This is meaningless. It is v dot v. We can't say v cross v. There's two reasons for that. First is v cross v. Just go back to that video of vectors, and then this thing will be clear for you. So it will be mod of first multiplied by mod of second multiplied by sine of angle between them. So v will make zero angle with itself, and ultimately everything will be 0. So that is why. And v dot v, now it is meaningful. V multiplied by v multiplied by cos 0, which is 1, so it is v square. So that is why we use v dot v equal to u square. So again u dot u plus 2as 2a vector dot s vector. Remember these equation of motion in vector form. Some of the question might come in this form, and I'm not telling you such type of problem right now, and we'll see some of the problem related to motion in 2 dimension in upcoming videos.